last video for the night, I think, determining the product of curved arrows drawn on a skeletal structure. I'm so glad you're wrestling with this. This is really very important. I have to ask, it goes like this. First of all, we have to ask, is it possible what these arrows say to do? I'm supposed to examine it below and then answer the question. Is it possible? So, if these electrons, can they go over here? Can these electrons go over here? And if they do, what's it going to do? Well, this nitrogen's not going to care because it doesn't have, it already has a lone pair of electrons. You can't tell, but it's got 3 bonds and a lone pair of electrons. This nitrogen's not going to care because it's going from a bond over here to a bond over here. But this carbon will care. So because you can't have a double bond on both sides and a hydrogen out here. But this carbon's going to, no problem, I'll just give those electrons over here to this nitrogen. And then that'll actually look like an amine or ammonia, right? So no problem. But what's going to leave, this is going to leave this carbon over here with a plus charge on it. Is that okay? Well, remember, in a previous topic, we were looking at major and minor resonance structures, and a plus charge on a carbon is better than a plus charge on a nitrogen. However, it's going to leave it without a full octet. So let's go here and say, is it going to be a reasonable structure? I think the answer is going to be yes. And if it's a reasonable structure, what's it going to look like? Let's draw it out. Da, 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 da. Oh, this is terrible, isn't it? I'm not even going to worry about the looks of that. Nitrogen, like there. It's going to have a double bond here. And this nitrogen's going to have a hydrogen on it. And a lone pair of electrons, right? Boom. And that's no problem, okay? But it is going to leave, and it's going to have a lone pair of electrons here too. I'm going to put that lone pair right there. Boom. But it is going to leave this carbon with a formal charge of positive. So I think it's reasonable. It's not going to be a major resonance project. Let's just product. I'm going to click solve, and let's see if that gives it to us. If the answer is no, it's going to be because we don't have a full octet here. Remember those rules in the previous video? All major need to have full octets. And this one doesn't. It's a carbocation. I'm going to click solve, and we'll see if we get the same thing. Boom. Yes, we do. Okay. So it's not going to be a major resonance contributor because it doesn't have a full octet, but it is reasonable. I just clicked solve, and it gave it to me. It gave me a prettier structure than the one I built. Okay, let's try another one. Okay. So if these electrons go here, and these electrons go here, that's going to give me a triple bond here to that nitrogen. And a double bond over here. It's going to be 5 bonds total. No, I can't do that. I'm going to show you what it would be. Let's say yes. It's going to be wrong, but let's do it, okay? 5. No, I don't want that. 5. Boom. Oxygen. Boom. Is it distracting that my structure's so ugly? Sorry about that. That's a double bond. It's going to be a triple bond then, right? And then this is going to be a double bond over here. And nitrogen cannot have 5 bonds. So the answer is no. But let's say that's what it is. And if that's true, it's going to leave a plus charge behind, right? Because this carbon lost some electrons. So I'm going to click solve, and we're simply going to go back to no, because nitrogen cannot have 5 bonds. And the answer is no. Let's do one more. And we'll say, all right, is this a reasonable structure? Can these electrons go here, and will that nitrogen still have a full octet? Yes. And if so, this carbon is going to say, hey, I can't have too many bonds, but it can push that one over. Yeah, no problem. And then if this carbon's saying, hey, I have too many bonds, but it pushes those electrons up. Yeah, this is legit. Let's go ahead and build this out. 1, 2, 3, 4, 5, 6. 1. The first one was a hydrogen, right? 2, 3. I'll try to build a little prettier this time. 4, 5, 6. Boom. Boom. Hydrogen, right? And that's a nitrogen. And if this is going over, that's going to be a double bond there. And now nitrogen's got 4 bonds. It doesn't like that. So it wants to have 3 bonds and 1 lone pair of electrons. But if it's got 4, that's okay. It just has a plus charge on it. This bond moved over to there. That's not a problem. Carbon doesn't care about where its double bonds are. It's no problem. And these electrons moved up to the oxygen, right? So let's go here and put an oxygen up here. And now it's got 3 lone pairs of electrons instead of 2. Not the 2 weren't shown, but they were there. And that's going to have a minus on it because oxygen likes to have 2 lone pairs of electrons and 2 bonds. And now it has too few bonds and too many lone pairs. It's going to be a negative. So yeah, this is a reasonable structure. It's not great because we have formal charges on here, right? But it works. It's fine. I'm going to click solve. And we'll see that that's what we get. Right? Same structure. Moved it over a little bit, but same structure. All right, so I hope that's helpful. You have to go through the rules again. All the structures have to have full octets and no more. You can't have 5 bonds on a nitrogen. And we have to have the fewest formal charges for major structures. And they have to be in the right place. But if everything's got a full octet, it is a reasonable structure. Okay, hope that's helpful.